How OpenAI uses C++ and Python. OpenAI makes use of many programming languages, and C++ plays an important but behind-the-scenes role. Here's how languages like C++ typically fit into the stack. 1. Performance-critical components. C++ is heavily used in parts of OpenAI's infrastructure where speed and efficiency are crucial, matrix multiplications, and tensor operations. The building blocks of neural networks rely on linear algebra routines that must run at very high performance. These are often implemented in C++, sometimes with CUDA for GPUs. Custom kernels. When PyTorch or other frameworks aren't optimized enough for a specific operation, engineers may write custom C++ and CUDA code for better performance. 2. Deep learning frameworks. Most of OpenAI's models are trained using PyTorch, which is primarily Python-facing, great for productivity and research iteration. Has a C++ backend, ATN and Torch script that handles the actual heavy lifting. Allows hybrid workflows where critical sections can be written in C++, while the overall control flow stays in Python. 3. Serving and deployment. For inference, when models are deployed to serve responses to users, latency is critical, so models are often exported to a C++ runtime, e.g., Torch script or ONNX runtime, to minimize Python overhead. This ensures requests can be processed quickly and at scale. 4. GPU acceleration, C++ CUDA. OpenAI's large models rely on GPUs, NVIDIA A100s, H100s, etc. The low-level CUDA kernels, written in C++/CUDA, interface with the GPU hardware directly. This is where tensor libraries like QBLAS CUDNN come into play. Engineers sometimes write custom CUDA kernels to squeeze out additional performance. 5. Ecosystem interoperability. C++ is also useful when integrating with other systems that aren't Python-based, handling infrastructure that needs compiled, low-level performance, e.g., memory management, distributed training pipelines. In short, Python is the front end for most of OpenAI's model development, but C++ is the engine under the hood. It powers the performance-critical computations, especially for training and inference at scale. Trade-offs. 1. Developer productivity versus raw performance, Python. Strengths. Very expressive, fast to prototype, rich ecosystem of ML libraries, NumPy, PyTorch, Hugging Face. Trade-off. Slower runtime performance and higher overhead compared to compiled languages. C++. Strengths. Extremely fast, gives fine-grained control over memory, threading, and GPU interfacing. Trade-off. Harder to write, debug, and maintain, especially for large research teams iterating rapidly. OpenAI uses Python for rapid research and iteration and C++ for bottlenecks. 2. Flexibility versus stability. Python side. Ideal for trying new model architectures, experimenting with training loops, or quickly adjusting loss functions. Researchers can iterate in hours or days. C++ side. Once a model reaches production, C++ implementations, e.g., Torch script backend, custom CUDA ops, stabilize the runtime for efficiency and reliability. 3rd. Training versus deployment. Training, Python heavy. Researchers define models in Python, PyTorch. Underneath, operations get dispatched to C++/CUDA automatically. This makes training accessible without having to manually optimize everything in C++. Deployment, C++ heavy. Serving millions of requests per day requires low latency runtimes. Models are exported to C++ backends, Torch script, ONNX runtime, TensorRT, to avoid Python's global interpreter lock, GIL, and overhead. 4. Ecosystem support. Python, community-driven, with abundant ML tooling. Most new research papers and frameworks use Python. C++, critical when integrating with hardware, NVIDIA GPUs, TPUs, networking libraries. Almost every high-performance ML library has C++ under the hood. 5. Trade-off philosophy at OpenAI. Default to Python for flexibility and speed of research. Drop to C++/CUDA only when necessary for hotspots that impact scalability, training huge models, or serving billions of tokens. Hybrid workflows. Python orchestrates, C++ executes. Summary: OpenAI balances Python's ease of iteration with C++'s speed and efficiency. Python is the creative playground, while C++ is the performance engine that ensures models train and run at scale without wasting compute.